Hello class, and welcome to this video, a brief introduction to x86 server virtualization and VMware Workstation 9 configuration tips and hints. In tonight's video, I hope to accomplish two things. First, I want to introduce the topic of virtualization. I want to explain to you what it is, where it came from, and why it's such a powerful technology. The other thing that I'd like to do this evening is to show you a few tools that those of you that are new to VMware Workstation 9 may not be familiar with. So let's go ahead and get started. x86 server virtualization. To understand this technology, it's necessary to go back before its widespread use. So to do that, to illustrate that, I've got an example here of what used to happen when a company needed to add a new server to its data center. So let's go ahead and look at this example. Let's say that your company needs to add a new database server. The new database server would be single-purpose hardware. That's where you see the 1-to-1. That means the ratio of hardware to applications was 1-to-1. An email server would just be an email server. A database server would just be a database server. A file and print server would be just a file and print server. There was no cross-pollination, if you will. A single server performed, for the most part, a single function. So let's talk about what it would take for a company to set up a new physical database server. Installing a server can easily take several weeks just to receive the hardware. And I'm talking specifically here about large enterprises. The reason this takes so long is because there's a long list of things that needs to be accomplished just to press the button to order the hardware. So, for example, it may be that your company or your department is restricted to just a few vendors. It may be that your finance department requires that you get bids from several different vendors before you can even place the order. It may be your company policy that you have to have your IT department sign off on any recommendations for the hardware that you need to get costed out or otherwise bid on by your vendors. All this takes time. But once the hardware is ordered, even then, it can take several weeks to actually have it hit your loading dock. Once the hardware has arrived, then your IT department must, install the hardware, put everything together, the hard drives, the RAID controllers, power supplies, memory, perhaps you ordered an additional CPU. All these parts need to be assembled. Now, sometimes, granted, this will come assembled as a whole server for you, and your IT department won't have to build it. But again, for most large enterprises, they typically prefer to build their own servers with their own people. So once the hardware is fully assembled, it should be subjected to what's called a burn-in test. A burn-in test is just like it sounds. It means that for a period of time, a week, 2 weeks, a month, the hardware is not in production. It's not being used to do anything yet. It's simply running. And you do this to make sure that none of the components fail. Your power supply doesn't fail, your fan doesn't fail, or fans rather don't fail. Any other components internal to the server or workstation don't fail during this burn-in test. That's your objective. Once the burn-in test has passed, then it's time to configure the machine, which means typically loading an operating system and then loading additional applications on top of that. This, of course, requires licensing and may require, and most likely will require, that is, specialized configuration. Once the applications have been installed and configured, then you'll be at the point to perform sandbox testing. Sandbox testing means that your server is fully functional, fully configured, and ready to be put into a production environment, but not yet put into a production environment. Many companies will run a new piece of hardware like a server in parallel to production servers for a period of time just to make sure that the performance is the same on the new server as on the old server, or at least as good. Once the sandbox testing is complete, then it's time to put the server into production. So this whole process from end to end, from the moment that you decide that you need a new server to the moment that that new server is actually performing real work in a production environment, can easily take 3 to 6 months in a large environment. Now, wouldn't it be nice if you only had to do that one time? Well, that's the magic of x86 server virtualization. You can cut out a lot of these steps by leveraging the power of virtualization. So, by taking this same example, let's say that instead of doing a physical server, you elected to do a virtual server. Now, granted, I'm glossing over a lot of background information for how you would get to the point to use a virtual server, but since we're concentrating on the stand-up period here, I'll just go with it. So let's say that instead of doing the physical server, you decided to do a virtual server. And let's say that, everything that we've talked about doing here, you had to do for a virtual server. The good news is here that once you've done that on the virtual side, you can clone or otherwise designate that image as a master image. And if you decide after you get this new server in production that you need another server just like it, you can clone it. And instead of having to go back through the hardware path, which again could take 3 to 6 months to acquire a new server in a large enterprise environment, by using the power of virtualization, you can simply clone your operational server, and with a few minor changes to the configuration, you can have a second server or more up and running in your production environment. So instead of taking 3 to 6 months for that second server to be placed into production, with virtualization and cloning, you could conceivably have a server that's ready to be put into production, that's been fully tested, etc., in 15 minutes. Depending on your hardware, it may take longer, but the point being that by having a virtual machine and being able to make copies of the same, you vastly reduce the time that it takes to stand up a new server. And that is one of the most powerful attributes of x86 virtualization. So the next bullet on the slide here talks about utilization rate. So in addition to being easy to stand up a new server, virtual servers also allow you to get better utilization out of your hardware. Depending on the industry study that you want to read, you'll see that average server usage rates are anywhere from 3 to 8%, which means that most of the time, most of your servers are idle. They're sitting there waiting for something to do. But while they're sitting there waiting for something to do, they're still drawing power. They still need to be cooled. They still need to be maintained, and all that costs money. So you can realize significant cost savings by reducing the amount of hardware that you have. So if you, instead of, I'll make up a number, instead of having 10 physical servers, let's say that you could consolidate that to one really large server that you had 10 virtual servers running on. So now instead of having to power and cool and maintain 10 separate servers, using virtualization, you have one physical server and 10 virtual servers. And those virtual servers, the patching and the updating and whatnot that goes on with them still needs to happen, but that administration can happen remotely and can be done anywhere in the world that you can establish an internet connection back to your system. So just to recap here, the power of x86 virtualization is in the ability to rapidly provision or create new servers, as well as save money by consolidating hardware from many separate pieces of hardware to a single piece, or at least fewer pieces of hardware. So again, in my example, instead of having 10 servers, using a product like VMware ESXi, you can consolidate that into a single server. So x86 virtualization draws its name from the family of processors that it uses. x86 is an Intel family of processors that has been around for a long time, and it's it's proven technology, and it's also very inexpensive. It's led to the development of something called commodity hardware. Commodity hardware means that you can buy these servers very inexpensively, and you can buy them from a number of vendors. So the big enterprises like this, because it gets them away from committing or otherwise getting locked into proprietary hardware, which is normally very expensive and can require specialized labor. But by using x86 hardware, otherwise known as commodity hardware, then that means that they can buy COTS hardware and software. COTS, C-O-T-S, means commercial off-the-shelf hardware. That means you can buy it from Dell, you can buy it from HP, you can buy it from IBM, Acer, whatever your favorite hardware vendor is. The hardware really becomes secondary. So, looking at my slide here, virtual servers are very flexible. As I just mentioned, once you create a master image, you can clone it to create any one of a number. There is no limit to the number of machines that you can clone. The only limit has to do with your hardware. Virtual servers can also do things that physical servers cannot. For example, you can migrate a virtual server without turning it off. Now, this is an advanced concept and will not come into play during our class, but it's important to know that there are some specialized functions that you can operate with or use with a virtual server that are just not possible with a physical server. Also, virtual servers can be modified without potentially buying new hardware. So I've got an asterisk on this one because it all depends on what your host system is like. If you've got sufficient RAM and hard drive space and whatnot to add an additional vCPU or additional memory or additional storage to your virtual machine, because it's already available in your physical host, then you're not required to change the hardware configuration of your virtual machine if it needs, let's say, an additional CPU, some additional memory, or some additional hard drive space. Of course, if your host is maxed out, then you would have to buy additional hardware. As mentioned previously, x86 server hardware is inexpensive commodity-based hardware, which again means that you can buy this hardware from any one of a number of vendors. You just have to decide which one you might prefer. I spoke a minute ago about consolidation rate, so let me take a moment here to describe that again a little further. A consolidation rate, or a usage rate of 1-to-1, was the industry standard for many, many years. If you had the need for a server, you bought a single server and it performed a single function. Well, virtualization released us from that. So now you can get much higher utilization rates out of your server because the servers that you do buy are much larger, much beefier, and can perform many functions at one time through the use of multiple virtual machines. One word about x86 virtualization. I keep referring to this as x86 server virtualization, and that's because that's where this technology got its start. VMware Workstation 9 got its start in the server world. That's where VMware began offering products. So the discussion so far, everything that I've said about servers, to an extent, applies to workstations as well. x86 virtualization offers two types of what are known as hypervisors. And a hypervisor, without getting too technical, is like a hardware abstraction layer. It's a thin software client that sits between your operating system and the hardware of your host. So your operating system, through the magic of a hypervisor, doesn't know that it's a virtual machine. It thinks and Microsoft Windows is particularly sensitive to this. It thinks that it has exclusive access to the hardware of the host, even though, again, it may be and should be sharing that host with many other virtual machines. There are two types of these hypervisors. A type 1 hypervisor is what's known as a bare metal hypervisor, which means that you install it directly on the server hardware. The hypervisor in this case is the operating system. Examples of this include VMware ESXi and Citrix Zen Server. A type 2 hypervisor is also known as a hosted hypervisor, which means that you have to install an operating system on the hardware before you can build any virtual machines. So that's what we're doing in this class. We're using VMware Workstation 9 as our type 2 hypervisor. You install that on your workstation, and then in that hypervisor in VMware Workstation 9, you have built at least 2 virtual machines, a Fedora Linux machine and a Windows 7 machine. So again, in this course, we are only required to use or talk about VMware Workstation 9, but you should be aware that there are many server products available in this space, and that's what's really caught the attention of enterprise data centers. A few notes about what x86 virtualization is and is not. A virtual machine is not an emulation or simulation. They are fully independent, fully encapsulated, fully isolated from the host and other VMs. That means that if a VM crashes, for example, if a Windows VM crashes and gives you the blue screen of death, it will not crash the host system and will not affect other VMs. It is completely separate. Also, I did field this question about emulation and simulation, so I thought it was worthy to add to this slide here. An emulation is a facsimile of another system, an exact copy if possible. It is an imitation and may require that the original system be running to remain operational. So, if you look at our description here at the top of the page, it is not fully independent, it is not fully encapsulated, and it may or may not be isolated from the host. So an emulation, again, is a copy of a system. A simulation, by contrast, is a subset of a known working system. So, for example, in other classes, you might have used software where you completed labs online. And those labs that you were completing online, many of them have canned answers. It's a simulation of a server, or it's a simulation of a workstation, meaning that they are offering you a subset of functions that they want to offer you to complete a given exercise. And in many cases, you may only be able to complete the exercise the way they dictate, because again, it is a simulated copy, not an actual copy of the host or of the operating system. So how does virtualization relate to cloud computing? Cloud computing, as we currently know it, is built upon virtualization. Not only virtualization in hardware, but also in storage and in networking. Everything is virtualized. And what that allows an enterprise to do is to provide resources on demand. As customers demand additional processors or additional servers or additional bandwidth or whatever it happens to be, this can be provided in an on-demand format by spinning up additional, or otherwise making it available, additional virtual resources. So cloud computing is sometimes referred to as utility computing, and most of the time those definitions are the same thing, the same technology, just by different terms. So cloud computing, and I've got some examples listed here. Cloud computing, as a user of a cloud service, you don't care about what the infrastructure that's required to get you your service. So if you're using iTunes or Netflix or Hulu or Amazon Web Services, as an end user, You want the same reliability from your computer resource as you do from a light switch. When you need light in your room, you flip a switch and the lights come on. You're not interested in how the power was generated or transmitted or how it got to your house or the details of the wiring. You simply want to know that when you go and turn on that switch, that your light will come on. And that really is the same sort of paradigm that's applied to utility or cloud computing. And virtualization is the technology that allows cloud computing and utility computing to provide the services that we've become familiar with. Now, there are three dominant service models. It's just worth mentioning because you may have heard these terms bandied about in the press before, but software as a service, infrastructure as a service, and platform as a service are the three dominant service models. And like I was mentioning, with utility computing, software as a service, something like a Salesforce.com, if you're accustomed to that CRM software, means that your service, in this case your CRM software, is provided through a company called Salesforce.com. Anywhere you can access a web browser, you can access Salesforce.com. You're not interested in the hardware or the licensing. The only thing that you're interested in is that you have access to your data when you need it. And Salesforce handles all the other technical details. That's an example of software as a service. So anyway, these are the three dominant models, and I thought it was worth at least mentioning here. The National Institutes of Standards and Technology, or NIST, spent several years developing a definition for cloud computing. If you're interested in learning more, I suggest you follow the link at the bottom of this page that will take you to Special Publication 800-145. Okay, that ends the first section for the introduction of virtualization. Hopefully, I realize that was a high-level overview of the topic, but hopefully that sheds some light on any questions that you might have been having about what virtualization is. If you still have questions or if you'd like additional information, please don't hesitate to send me an email. Now I'd like to shift gears a little bit and share with you 5 common operations in VMware Workstation 9. Again, those of you that have been using this product for several classes will find this to be old hat. But if you're new to VMware Workstation 9, then it's essential that you become familiar with the tools or with the operations that I have outlined here. Specifically, I'm going to show you how to clone a virtual machine. That means to make a copy. How to create a snapshot of a virtual machine, which is a sort of a moment in time clone of a virtual machine. How to add hardware to a virtual machine. How to adjust the hard drive capacity of a virtual machine, and how to adjust the RAM of a virtual machine. Also, just a couple of points for you. Always shut down a VM gracefully, just as you would a traditional workstation. If you don't do this, it's like going over to your workstation at home or work and just unplugging it. Anybody that's used Windows for any period of time knows that Windows does not respond well to that. Also, please install VMware tools, especially for Windows systems. The principal benefit is a smoother video experience, but you can also find, depending on your host system, that you might have problems with, well, gosh, any one of a number of systems, but one of the ones I see most commonly has to do with network drivers. So please do yourself a favor. If you're creating a Windows virtual machine, go ahead and install VMware tools. VMware will prompt you for it and will ask you whether or not it can install it, but please allow it to do so. Your experience will be better for it. So let's go ahead and get started. Okay, so here is my desktop. As with the previous tutorials, we're going to start VMware Workstation by double-clicking it. And here we are presented with the VMware Workstation 9 desktop. Now, I'll direct your attention to the left pane first. You notice I've got 3 virtual machines created. Now, the first thing I wanted to show you how to do is how to clone a virtual machine. Now, cloning, again, is just making a copy of a particular virtual machine. So I've got a running virtual machine and one that's turned off. To create a clone, the machine has to be turned off. So I'll show you what happens otherwise. Right-click on the virtual machine that you would like to make a copy of, which you would like to clone. You'll notice that since the virtual machine is running, most of your options are grayed out. Again, that's because your virtual machine is running and you can't perform these operations. Now, this virtual machine is turned off. I'll click once to select it, and then I'll right-click. And you'll notice that I've got many of those grayed options now available to me. So, in this case, we want to create a clone. So we go to Manage, and you'll notice that Clone is the second option on this menu. So we'll select Clone. Click once to select the option. That opens the Clone Virtual Machine Wizard. We'll click the next button to continue. You've got two options on this page: the current state in the virtual machine and an existing snapshot. But we haven't created any snapshots, so the only option we have to copy this machine is to copy the current state. So you'll leave this page at its default and click Next. The next screen you'll see is called Clone Type, and on this page you have two options. You can create a linked clone or create a full clone. I recommend that, almost without exception, that you create a full clone. Unless disk space is a real consideration for your host, in other words, you don't have a lot of disk space, then I would always select the full clone option. Full clone means that anything that you do to your virtual machine, the clone, will not affect the host. If it's linked, it can cause problems. And as you'll notice here, it says, however, it cannot run without access to the original virtual machine. So again, for a single workstation installation, this is not likely to cause a problem. But as many of you graduate onto using this and other virtualization technologies, specifically ESXi, you'll find that creating a full clone is really the better option. So I'd go ahead and get in into the habit now. So we'll go ahead and click the next button. You can rename your virtual machine here anything that you'd like. The default name is clone of whatever the current name is. So VMware has selected the name clone of Windows 7 x86 parentheses 2. So we'll leave that for the time being. Also, you have the option here to change your location. So again, if hard disk space is a consideration for you, you may want to go ahead and browse to a different location. Otherwise, if you're satisfied with the default location, click the Finish button to launch the operation. Depending on the speed of your system, in other words, the amount of memory that you have available, the speed of your CPU, the number of disks that you have available, and the spindle speed, this operation can take just a few seconds or several minutes. I will return when this cloning operation has completed. Okay, my clone is almost complete at this point. The entire operation took in the neighborhood of 5 minutes, which is not unusual. I would remind you that your experience may differ, and if it takes 5 minutes to 45 minutes, that I would confine that to be an acceptable range of variation. Again, it all depends on the speed of your host system. So if it does take longer, do not be concerned. So once the machine is cloned, we'll click the Close button to close out the clone virtual machine wizard. And you'll notice once we close out the clone wizard, we have a new virtual machine in our left plane. So again, you can change this to any name that you might like. That's the default name. And changing of the names for VMware, the display names for the VMware, has no effect on the server name in the actual server. So a couple of things to mention about cloning. Now that you have cloned a machine, that means that everything has been cloned. If you have a static IP address, for example, that means the IP address for your clone machine is the same as the original machine. So you may need to go in, start up your cloned machine apart from the host machine. So if you, in other words, the machine that you cloned it from, shut it down. Bring up your your cloned machine and make any changes that you need to make to the server name, to the network configuration, or any other variables that might conflict by having an exact copy of the machine available on your virtual network. That covers how to make a clone. Again, very high level, and you can make a clone of a clone as well, but the virtual machine does need to be turned off. I will right-click on the machine that I would like to make a clone of. I'll select the Manage option, and then select the Clone option off of the menu. So that's how we create a clone. Okay, what I would like to show you next is how to create a snapshot. And a snapshot is a point-in-time picture of your operating system. So let's say, for example, that you need to install a patch on your system, but you have some concerns about the behavior. You're worried that it may crash your system. You could do something like create a snapshot such that if the installation fails or if you have any problems, you can roll back to a known good state. It would erase or otherwise ignore any sort of updates that had happened. So that's the power of a snapshot. So much like creating a clone, your virtual machine does need to be turned off. Then you use the same right click to select the menu, and you notice snapshot here has its own option. So we'll take the first option to take a snapshot. VMware adds the default name snapshot 1, and you should add some description here so that if somebody comes behind you to work on a virtual machine and they see all these snapshots, that they'll know what they're for. So again, a common reason might be to test a patch. So we'll say pre-patch installation. And what that tells me is that snapshot 1 was taken before the patches were installed. So then we'll click the option to take the snapshot. And you'll notice that that largely happens in the background. We don't have a wizard that pops up like we do when we clone a machine. So now, to make sure that that snapshot was actually taken, we can go back to the virtual machine that we took the snapshot for, right-click, go to snapshot, and you'll notice that we have a new option here, revert to snapshot 1. You also have an option here to use something called a snapshot manager. So I'm going to go ahead and click that. Creating a snapshot manager or using the snapshot manager is useful if you have multiple snapshots, hence the name snapshot manager. Since we have just one snapshot, it's not very exciting. Let's say that you went through again, or you were testing a patch and you did not create a snapshot, and this patch caused your virtual machine to become unstable. Well, if you don't have a clone, if this is your original machine, for example, then you're stuck just like you would be in a physical environment, which means that you will more than likely need to reinstall your virtual machine. So a snapshot can save you the headache. There are some issues surrounding snapshots, however. For our purposes, there won't be much of an impact, but in a virtual environment, an enterprise virtual environment, if you have a snapshot attached to a server in an enterprise environment, you will not be able to migrate that virtual machine to other servers. The other consideration with snapshots is that they do require space. So again, if you are pressed for hard drive space, I would not recommend that you create a bunch of virtual machine or snapshots. I suggest that you take one or two just so that you can see how the technology works. But if you've got a 30 gig host image and you take a snapshot of it, then you can potentially use up another 30 gig for your snapshot. So again, I would ask you to use this particular option sparingly. I'm going to go ahead and close this window. And the next topic we're going to talk about is how to add hardware to a virtual machine. You're going to get used to this menu, and you're going to get used to this instruction. You cannot change the hardware configuration for a virtual machine while it is running. So again, using this same virtual machine, Windows 7, I'm going to right click and I'm going to go all the way to the bottom and select the settings menu. You'll notice when the settings menu loads that I've got all sorts of devices listed here in the left-hand pane. And at the very bottom of the left-hand pane is a button called Add. So let's say, for example, that I needed to add some hardware. I'd go ahead and click the Add button. It is not related to which option is selected at the time that you select the Add button. So you can disregard where the highlighter bar is resting when you click Add. So let's say that I need a network adapter. I select the network adapter and then the next button. I've got a number of options here. I won't discuss those in this particular video, but so for our purposes, I'll leave NAT as the preferred option. And we'll select Finish. You'll notice that just like that, I have got a second network adapter. So here's the original network adapter, and here's the second network adapter. So it's just that easy. Again, you notice I didn't have to buy any additional hardware. I didn't have to make any other changes to the system other than say, hey, I would like to add this additional piece of hardware. It's just as easy to remove a piece of hardware. So I'll leave my network adapter 2 selected, and I'll select the Remove button. Just like that, my new hardware has been removed. I'll go ahead and click the OK button to close the virtual machine's setting window. The next operation I want to show you is how to adjust the hard disk capacity of a virtual machine. Now, as I have shown you with previous operations, you must turn your virtual machine off. Once the virtual machine is turned off, you can click once with your left mouse button to select it. It will be highlighted in blue as mine is here. And then select the right mouse key and select the bottommost option here, which is Settings. Now, we're interested in changing the hard disk capacity. So I'm going to click with my left mouse button once to select hard disk. And it brings up the menu that you see here. I'll click the pull down menu for the utilities option. And you notice that I've got a number of options here. We can expand and compact this particular virtual disk. Now, my virtual machine has a snapshot attached to it, which means that this is going to fail. But let me show you what it looks like. We'll go ahead and select the expand option. And you'll notice here it says disks can't be expanded if they belong to virtual machines that have snapshots. To expand this disk, either remove the snapshots or use VMware vCenter Converter. So we're not interested in using Converter at this time. So we're going to say OK. And we're going to click Cancel to close the virtual machine settings window. We're going to leave our virtual machine selected in blue. We're going to right click and we're going to select the snapshot option from the menu and then the snapshot manager option. We're going to click the snapshot in question. In this case, we only have one. And we'll click delete. Now this, of course, will return the virtual machine to its pre-snapshot state. So if you have anything that you want to save, it may be a better idea to add an additional hard drive, a new hard drive, as opposed to expanding an existing one. We'll click Close. At this point, we can go ahead and expand our current hard disk. So we'll click once to select the menu or to open the menu. We'll click Settings. We'll click with our left mouse button to select Hard Drive. And from the Utilities pull-down menu, we'll select Expand. Now at this point, we'll see that our maximum disk size is the default that we have set, which is 30. We're going to bump that up to 35 gigs and select Expand. As I've said previously, depending on the capacity of your system, the speed of your CPU, the amount of memory you have, etc., expanding your virtual disk may take many minutes, anywhere from 5 to 45 minutes to complete the operation. Unless you get a specific error message, or unless your progress bar stops moving completely, I would not cancel or otherwise try to stop this operation. In my case, having completed this previously, I know that this part of the operation goes fairly quickly. So we'll stick with it while the expansion completes. While we're waiting for this to complete, it is worth noting that if you do have a snapshot that you want to preserve, but you must expand the size of your hard disk, there's really no other option. You have to decide which one is the better deal. Now, the VMware converter option, when you convert or otherwise clone another system, and you can do what's called a P to V, which is a physical to virtual, or a V to V, virtual to virtual, when you select that option during the configuration stage, you have the opportunity to change the size of the hard disk for the machine that you are cloning. So let's say that you are cloning, for example, a physical machine that has, I'll make up a number here, 5 gigs of available hard disk space. If the reason that you're cloning this machine is that you don't have enough hard disk space, you can add it during the clone. So if, again, you only have 5 gigs of hard disk space available, but what you really need is 100 gigs, you can change that during the use of the VMware Converter standalone product. Now, of course, you have to have the capacity available on your new host system, wherever you're putting that new image, but you do have the option to change the capacity of the hard drive during the clone operation. And we're almost finished here. This is not an unusual circumstance, and there we go. The disk was successfully expanded. You must repartition the disk and expand the file system from within the guest operating system. So what they're telling us, and we'll go ahead and click the OK button to close this, and I'll direct your attention here. You'll notice that our new disk is in fact 35 gigs. Now, Windows won't automatically recognize that, so you'll have to go into Disk Manager on the Windows side to make use of your new space. So I'll go ahead and click OK to close the virtual machine settings window. The last operation I'd like to show you is how to adjust the RAM of a virtual machine. So you should be familiar with the routine at this point. With your virtual machine shut down, right-click the machine that you need to change. We'll leave our Windows 7 machine selected here. Select Settings from the very bottom of the menu, and then select Memory. Now in this case, we want to add memory. Currently, we have 2 gigabytes of memory available. Well, let's say that we need to change that to 4 gigabytes. So we'll change that to 4096. And you'll notice here's a slider as well. You could use the slider here to adjust the memory. But in our case, since we know we wanted 4 gigs, we went ahead and just did it the manual way, which is to add it directly into the text box window here. Either method will work. I'll also draw your attention here to recommended memory sizes. VMware has calculated the maximum memory available, as well as a couple of recommended memory points for you. The recommended memory is 2 gigs, and the absolute minimum is 1 gig. So again, just for demonstration purposes, we're going to set this to 4 gigs, and then select OK. Now, before I open the menu again, I'll draw your attention here to the Device tab on your Windows 7 menu, and you'll see that the memory has changed to 4 gigs. We'll go ahead and go back into the menu to confirm this. Right-click on the virtual machine that you just updated. Select the Settings option. And we'll see here that just as indicated on this menu over here, slide this over just a bit, just as was indicated over here that we have 4 gigs of memory, we can see here likewise we now have 4 gigs of memory. So that's pretty straightforward. And of course you can adjust it the same way downward. We'll go ahead and use the manual option here. I'll enter in 2048 for 2 gigs of memory and select OK. And you notice that the update happens almost instantly. Well, that ends my presentation for this evening. If you have any questions, comments, or concerns, please don't hesitate to send me an email. I hope that tonight's presentation has been helpful, and thank you for listening. Have a good night.